Now that we have a little bit of a basic understanding of probability, let's look at a few definitions that are important here. The first is going to be that of an event. When I defined probability, I did use the word event, but I never formally defined it, so let's define it. An event is just a collection of one or more outcomes in a probability experiment. So it could just be one possible outcome, or it could be a combination of outcomes. And a simple event is a single outcome. So if we're looking at the type of event that results from a single outcome, we call that a simple event. So let's do one more definition, and then we'll do examples of distinguishing between these. The next thing we look at is the sample space. The sample space in an event is all possible outcomes. And so it's everything that could possibly happen. And the last thing we'll point out is if I look at the probabilities of all possible simple events in a sample space, then if I add those up, I will get 1. So if I take all of the simple events and add their probabilities, it will be 1 every single time. So let's look at an example of distinguishing between events, simple events, and sample spaces. Let's suppose that we're parents and we want to have 3 children. And in this, we want to look at the sample space of the possible outcomes of children. Well, we could have 3 girls. We could have 2 girls and a boy. We could have a girl, a boy, and a girl. We could have a boy, a girl, and a girl. We could have 2 boys and a girl. A boy, a girl, and a boy. A girl and 2 boys, or we could have 3 boys. So everything I've written down here, this is the entire thing of the sample space. This is all of the possible outcomes that we could have. An event would be something like 2 girls. In that case, we would have these 3 outcomes. A simple event would just be a single possible outcome. Maybe something like boy, boy, girl, since that's only one possible outcome. The other thing we'll look at here is known as the complement. If we have an event A, the complement of that event is the event that A does not occur. And it's denoted by A with a little exponent of C. And the important thing here is to note that the probability of A plus the probability of the complement is equal to 1. So as an example, if there's a 30% chance that it's going to rain today, then there's a 70% chance that it won't rain. And those events are complements. The chance that it'll rain would be A, the complement, not rain. And that should add to 1 since those are our 2 possibilities. Another example, let's suppose at our school 45% of people get a flu shot every year. We want to know that the chance of a randomly selected person didn't get the flu shot. So we don't want the probability that they got a flu shot is 45%. So the probability of, I'm going to write flu shot C for complement, would be the chance that they did not get a flu shot, which is 55%, since these numbers do need to add up to be 1 or 100%.